What do you think is weight? Because the weight force is defined as Fg equals mg, Fg changes when g varies. On or near the surface of Earth, g is approximately constant, so an object's weight does not change appreciably as it moves around near Earth's surface. What happens if you stand on a scale in an elevator? As long as the elevator is in equilibrium, which means the net force acting on it is zero, the scale will read your weight. What would the scale read if the elevator accelerates upward? You are the system, and upward is the positive direction. Because the acceleration of the system is upward, the upward force of the scale must be greater than the downward force of your weight. Therefore, the scale reading is greater than your weight. If you ride in an elevator like this, you would feel heavier because the floor would press harder on your feet. On the other hand, if the acceleration is downward, then you would feel lighter, and the scale would have a lower reading. The force exerted by the scale is called the apparent weight. An object's apparent weight is the force an object experiences as a result of all the forces acting on it, giving the object acceleration. Imagine that the cable holding the elevator breaks. What would the scale read then? The scale and you would both accelerate with A is equal to minus g. According to this formula, the scale would read 0, and your apparent weight would be 0. That is, you would be weightless. However, weightlessness does not mean that an object's weight is actually 0. Rather, it means that there are no contact forces pushing up on the object, and the object's apparent weight is 0.